This is Honors Algebra 2 Pre-Calculus. We're doing 10.4 in Pre-Calculus, which is Hyperbolae, and this is example 6, which is actually the textbook's example 3 on page 728, but I am using it. So here we go. So we have 4x squared minus 3y squared plus 8x plus 16, and we're asked to sketch by hand, which is going to involve finding the standard form of the equation, because that's how we can sketch by hand, and also write the equations for the asymptotes. So even though you're not expressly asked to find the equation in standard form, you kind of have to sketch by hand. So I'm going to go ahead and do that first, right? So let's slide over here and do some completing the square. All right. So we have a 4x squared plus an 8x, right? I'm going to separate that from the minus 3y squared, and I'm going to go ahead and add the 16 to the other side. Subtract the 16 rather to move it to the other side. Cool. So I'm going to complete the square for the x, right? I yank out the 4, because you always yank out the entire leading coefficient, and that's going to make this a 2x when I factor that out, right? And then really, I'm just pulling the 3 out. If you want to write this as a y squared plus no y, you could. Like, I mean, there's no square to complete here. It's a 0. You can just leave it as a y squared, right? So you can do this if you want. I think it's a weird choice. I think the easier choice is just to recognize that in this case, you're just going to have a y squared because it's y minus 0 quantity squared. And on the other side, I have the minus 16. So I only have to complete the square here, right? I do my triangle step by dividing by 2 and get a plus 1. When I square it, I'll add 1, but I really added 4, right? So I'm going to have to add 4 to this side, right? So what's going to happen is I'm going to have a 4 times the x plus 1 quantity squared minus a 3y squared equals a negative 12, right? Well, in order to get this side to be a 1, which is what I need, I'm going to divide everybody by a negative 12, right? And what that means is I'm going to end up getting a negative x plus 1 quantity squared over 3, right? Plus a y squared over 4 equals 1. So if I use this in standard form, right? So if we slide back over here and write our standard form equation, that means that my standard form equation is going to be y squared over 4, because that's the positive one, minus an x plus 1 quantity squared over 3 equals 1. So what this means, right? So this is the equation I need to use, right? So I'm going to erase all my completing the square work so that I have some more work to go ahead and do the other stuff. So now I need to go through the list of finding the center and what A is and which direction A moves in and what B is. Okay, so first thing I can spot is that my center, again, I wasn't expressly asked to find it, but you can't graph it without doing this. My H is going to be, it's x minus H, so my H is a negative 1, and my y coordinate of the center is a 0 because that's a y minus 0 squared, right? I notice that A is a 2, right, because it's the square root of 4, in the y direction, right? And that B is apparently the square root of 3, right, because B squared is a 3 in the x direction, okay? So if I sketch the graph of this, and that's really all I need to sketch this graph, right? I'll be able to draw the boxes, I'll be able to put the vertices. So it's kind of worth noting that a root 3 is about a 1.7, give or take. It doesn't matter. You could basically call it around a 1.5 because, again, visually you just want the rough idea. On your graph, there's no good way to put a root 3. You have to kind of approximate with a decimal, but you should still consider it a root 3. So let's go ahead and put our center, right? So if we graph this, right, my center is at negative 1, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so my center is right here, right? That's my center. And then in the y direction, I'm going to move up 2 units, so that's going to be one vertex, and down 2 units, so that's going to be the other vertex, right? And then I'm going to move left and right 1.7-ish, right? So like here, right? So that's one of these sides, and then the other one is maybe here. And then this is the box that I'm going to draw, right? And then through that box, I'm going to draw my little invisible diagonals, which I draw as dotted lines, and those are going to be the asymptotes that I'm going to find the equation for, right? So the last thing I do in order to sketch this is, looking for my other color of marker, I start at the vertex and I draw my branches along the asymptotes, okay? So there's my sketch. So that's number 1. I did it. I sketched the graph, right? But now I need the equations of the asymptotes. So what I mentioned in the video when we talked about the equations for asymptotes is that when you have the graph, you can kind of just do this by visual inspection. If I want the slope of this line from the center, this thing has a rise of 2 and a run of root 3, right? And the other line goes in the opposite direction. So this line right here has a slope of 2 over root 3. And this line over here, the one going in the other direction, has a slope of negative 2 over root 3, right? So essentially, my asymptote equations are, I use the center as the only point that occurs for both of them. So y minus the y value, which is 0, equals the slope is going to be a plus or minus 2 over root 3, because this is the positive one. This line has a positive slope. This one's the same slope but negative, right? Times x minus a negative 1, which would be x plus 1. So those are the equations of my asymptotes. Now, if you wanted to rationalize, you could. I don't think that there's a significant reason that you'd want to. If you wanted to write these as two different answers, you would just write them as separate answers instead of the plus or minus, right? So you could write y equals 2 over root 3 times an x plus 1, and your other equation could be y equals negative 2 over root 3 times the quantity x plus 1. And you could leave this as a y minus 0 on this side. I just don't know that there's any real reason since it's a 0.